Assalamualaikum and good day everyone. We are now in the third chapter for speech part. That would be the physics of speech. Uh, a disclaimer, most of the content from our slide this week is coming from a few of the textbooks, um, mainly Latchford and um, Latchford. There are two books by Latchford. The slides also obtained from David Given and Teresa O'Neill. I try to make it very simple. So this chapter, I only divide it into three parts, but each of them are having varying length. For speech analysis, we are going to play with the hands-on. So that's the reason why in the e-learn there are list of tools that we're going to use, and I specifically say we're going to use Pratt for speech analytics. But first, let's go to the acoustic phonetics. So if you refer to the previous lecture recording, there are three highlights of phonetics when I do it against, when I compare it against phonology. So there are articulatory phonetics, which is concerning the how we produce the speech, concerning the position, the movement of the lips, of the tongue, of other articulators that involve in order to produce an individual speech. So that was what we've covered last week mainly. There is also auditory phonetics, which concern with speech perception. What do we perceive by the speech? And this week, we're going to focus on the acoustic phonetics. So acoustic phonetics is concerning the properties of the sound wave. So we are going to analyze the sound wave as a whole um, and break it down into their components that forming the sound. So which is transmitted through air. So when we talk to our friends, we are speaking face to face, and there's only air in between us or our mask nowadays. There could also be another medium. So if you are familiar with Malay classical movie by P. Ramlee, there's a few actually scene where him being the main character put his ears on the wall to listen to what is the next door person are conversing about. So of course we prefer to communicate in a normal way, but if you're picking on someone or you're eavesdropping on someone, the medium could be the wall between you. So in general, speech is not something that can be touched. It cannot be seen, but definitely can be heard. Um, and we can still measure it, like uh, the changes of air pressure in the air causing waves on the ocean. So when we talk about speech waveform, there is a certain measurement that we can apply, and it can be visualized in order for us to calculate and to use a statistical representation to represent the speech, the thing that we cannot see and touch but we can hear. If someone insists that we can actually see speech, most probably it is the visualization of the sound that we produce in the form of waveform like this. So this is the raw form of a speech waveform. The recording is pronouncing father, father. Right? Pause the video for a moment and try to identify what information displayed in this very basic and raw data. Parameters available in a raw waveform. One is the duration. You can see here 0 is the starting point, 1.0568 for it is the end time for this recording. but the actual recording happened from the actual sound occurs on from here to here. What is the next parameter? That would be the amplitude. So the amplitude is 0.9385 minus 0.8193. Do they represent anything? That is the interesting part. The basic parameter of speech signal is the two that we highlighted, we seen just now. However, when we talk about speech, the main parameters involved is about intensity or loudness. And we also talk about frequency. Some people's voice is much higher frequency, and some people's voice are much deeper. So they have a different frequency that characterize one person to the other. So from this information, we can derive this information. So in order for us to analyze speech signal, we need an analog to digital conversion. Obviously, speech is analog. When we talk, is a waveform. So when we put it inside the computer, it has been digitized. Sorry. And we also need the mathematical definition of filters and transformation. So if you are in electrical engineering, or you are specifically in speech processing or digital signal processing domain, there are hundreds of equations involved in order for us to retrieve some information from the speech signal. So if you are wondering, do we have to go through this? No, we are not going to touch to the level of the engineering aspect or the signal processing aspect. We are only analyzing the speech. Before we can process, before we can analyze speech, we need to know what makes the speech. Yeah? So some term and concept. So the first image is a sinusoidal signal. Just bear in mind our speech sinusoidal model, but it's not simple like this. Okay, when I say simple, because in this diagram, it the flow is very consistent. In speech, it won't be as beautiful because it is a very complex sinusoidal signal. So from a raw signal, we have the time over amplitude. We can't actually retrieve some information like frequency. You may be wondering, from this information, how are we going to retrieve the frequency? However, we know T is equal to 1 over F. If you go back to your form 5, I think frequency is equal to 1 over T, temporal. So we can retrieve what is the frequency of a particular signal at a particular given section. When we say the word frequency, it referring to the cycle per second, or how many cycles are produced by the speech signal in 1 second. However, inside vocal tract, there are a lot of frequencies that we have to familiarize ourselves with. So in a simple sinusoidal signal, we call the top here as crest, and we call the slope down here as groove. Every time we look at a sinusoidal signal, we have to know the wavelength because a calculation is always needing us to check the wavelength. So a wavelength is where we can find the distance from one top or one crest into the next crest, or we can also say from the y-axis where it's 0 until we meet it here again, one complete cycle, or we can say it's from one throw to the next one. And we know already that amplitude is the y-axis. Let us first look at the frequency and amplitude. Yeah? So how can we get frequency? So we know we have the amplitude, we have the duration, the time duration. And in this example, a snippet of recording. Okay, this is speech. From the speech signal, the speech waveform, like the father waveform, if we zoom it in, we can see that the it will look something like this. So they have one crest and then it have one trough here, and then it crests another point, but that crest is not as high as this. So this is not one cycle yet. This from here, here is one cycle. Why am I making a point about this? In order to calculate the frequency, f is equal to 1 over t. So that's how we get the frequency, or that is the formula we're going to use in order to calculate frequency. Frequency would be equal to 1 over time. But time here is not referring to the snippet that we extracted, because this duration is something that we can extract when we're doing analysis later. This time need to be we need to get the t for only one section phase. So most of the time you will not have only one phase, because if we extracted one phase, then we are not actually trying to average. There are possibility of that particular signal being a noise, so we tend to take slightly longer for that particular section in order to calculate the frequency. So how can we compensate? So because f is equal to 1 over t, here the t is given 0.03875. So that will make 1 over t to be 1 over 0.03875. Sorry about the handwriting. This is for how many phase? This is 1, 2, 3, and if you count, you will have 10 phases. That also means by right, we have to divide this by 10 first. So if we put here, it will be equal to, bring it up, hence in order to calculate the frequency, that is where the value come from. Just bear in mind, when we are doing this kind of calculation, the frequency that is the waveform referring to is the vibration of the vocal fold. Later we will call this as a fundamental frequency. Okay. Now, next is about the amplitude. To get the average amplitude over time range, we have to calculate the root mean square amplitude. Amplitude, to be honest, it didn't represent a significant or noticeable features of the speech signal. However, we need the amplitude in order to do the very complex calculation of getting the sound pressure level, SPL. Use this amplitude. We use this to calculate intensity. So using the square root of amplitude, we get the power of signal. And then using this formula, we can get the intensity of the sound. I'm going to stop the video here. The next one, we will talk more about the loudness